All right, next up, please. Let's look at the ROC series circuit. In the part one, we looked at the RL series circuit where we had a resistor be connected to an inductor in series. Now let's look at a resistor being combined with a capacitor in series. Now it follows the same concept as the first one, where we said we are combining what there voltage drop, right? Combine voltage drop and equate to what there the electromotive force according to who's there Kirchhoff's voltage law. The same concept works here. For this one too, we'll be combining voltages here, but for this case, we'll be using a different approach. Recall that in the part one, we said that I is equal to what there? dq over what there? dt, right? Yeah? That's the rate of flow of charges. That's number one. Also recall that from whose law that Q, do you remember this formula from physics that Q is equal to CV? Do you remember this? Yes, from physics, right? That the charge is equal to what there? The capacitance times what there? Voltage. You have this. So when it comes to a capacitor there, in terms of capacitor there, you can get voltage in terms of capacitor by saying voltage is equal to what there? Charge over what there? Capacitor or capacitance. So in essence, for this one here, the voltage drop, note number one, voltage drop in the resistor, that's V of resistor, is equal to, from Ohm's law, we said this word there, R times current, as we said earlier. But in this case, I'm expressing current in terms of what there? Charges. And that means VR is equal to R times dq over dt. That's the first thing there. Number two, the voltage drop in what there? The capacitor. You've seen it here. That's V of C is equal to Q all over C. Okay. So if you use Kirchhoff's law, combine the voltage drop here and voltage drop here, it will be equal to what there? E. Combine voltage drop for R. That's this one here. Voltage drop of the resistor is R dq over dt plus combine for the capacitor. What do you have there? Q all over C from Kirchhoff's law is equal to what there? The electromotive force. If we shift this, we can see that this becomes R into dq dt plus 1 over C times Q is equal to what there? E. So we have this. So basically, this becomes a first order non-homogeneous. Of course, if you want to make this to be subject to the formula, what do? Multiply. You can divide by R or multiply by what? 1 over R. Multiply it by 1 over R, what happens here? It cancels this. 1 over R times R, it cancels out. I'm having dq dt plus multiplied by 1 over R. What do you get there? 1 all over RC times Q is equal to, multiply this by 1 over R. What do you have there? E over R. From here, start taking what's there? Integrating factor, and you get your answer. But don't worry, we're not going to that route this time. Do we have to derive the equation? Or you can follow what we did in the first part and derive the equation. But don't worry, let's not go through that. We'll take an example and then we solve this. Always remember how I got this stuff here. I didn't just give you formula. I explained how we did it. All right. Let's take one example or two examples on this, and we're good to go. Let's take an example on RC series circuit. An electrical circuit is connected to an electromotive force of constant voltage 60 volts. If the said circuit consists of a resistor of resistance 5 ohms, capacitor of capacitance 0.05 farad, and initial charge is Q um, of 0 equal to 0, find the charge and the current at any time t. That's the task there. So we have to find two things there: charge and what again there? Current. All right. So how do we solve that? The first thing we want to do is to list that parameter. They give you electromotive force E. How many? Six, 60 volts. 60 volts. What else were you given there? Resistor R of resistance. How many? 5 ohms. What else? Capacitance or capacitor of capacitance 0.05 farad. And you're also given that Q of 0 it's equal to 0. Okay. So let's recall now this is an ROC circuit. In your exam, you'll not be told for an ROC, for an RL. Use your eyes. They give you R and C, so it's ROC circuit. What equation do we use here? The equation here is that R dq dt, this plus 1 over C times what there? Q is equal to what there? E. Right? Let's impute values. What's the value of R? Or if you want to, you can make R. You can make this one, substitute the formula first if you want to. Right? If you want to, well, that still works. Let's make don't worry, make dq over dt to be unity, the coefficient to be unity. So I'll say multiply by 1 over r. 1 over r times this cancels out. We have dq dt plus, so 1 over r times this, 1 times 1 is 1, r times c is RC times Q. It's equal to 1 over R times E gives you E over R. So just simply take your time, multiply each of these by 1 over R. This by 1 over R, it cancels this, you have this. Multiply this by 1 over R. 1 times 1 is 1. R times C is RC. Bring down the Q. It's equal to, multiply this by 1 over R. It gives you E over R. So we have this. Let's impute values. Substituting values. Substituting values. If you want, you can solve without values and then substitute at the end, but that would take you so, it makes the thing looks complex. So let's just substitute at once. Let's substitute at once. I have the Q all over the T plus 1 all over, what's R? 5. What's C? 0.05 into Q is equal to E all over, what's R? 5. Oh, E has a value, sorry. Is what there? 60. Thank you. To have this. So I'm having this as dq over dt plus, please punch 1 all over this. What do you have? 4. That's 4 times q. It's equal to 60 over 5. What do you have there? 12. Please observe this, please. Just punch this. 1 divided by 5 times 0.05. You have 4 there. All right. So we now have a differential, a non-homogeneous ordinary differential equation. Let's solve this. Let's get integrating factor. We know that IF is equal to what there? Exponential integral of what there? U of x, which is whatever thing is attached to Q. That's what there? 4 of what there? dt. If you work on this, what do you have here? Exponential. Integrate 4t. What do you get there? 4t. We've done this over and over and over again. So 4t. That's my integrating factor. All right. So multiply by integrating factor. That's exponential 4t. Here, what do you have here? Exponential 4t multiplying everything here. That's this equation here. What do you have there? This over dt plus this 4 times q, it's equal to 12. So I have this. Let's expand this. What do you have here? This and this exponential 4t dq over dt plus the 4 comes first. This, then take this one next, exponential 4t, then add your q there. So 4 into this, it's equal to this and this. You have 12 exponential 4t. So you have this. We've said what we did, first order non-homogeneous ordinary differential equation. This becomes what there? D all over what there? dt of what there? What's the variable here? Q. Q times your integrating factor, exponential 4t. So this is equal to 12 exponential what there? 4t. So move this man over here. I have d of q dot exponential 4t is equal to 12 exponential 40 dot dt. Right? Dt goes over here. We're having this. Integrating. You know what? Let me just write it down here. Integrating I have the integral of d q dot exponential 4t. This is equal to the integral of 12 exponential 4t dt. Integral cancels differential. You have q dot exponential 4t. It's equal to solve this, move 12 outside integral sign, becomes 12 integral of exponential 4t dt. So you're moving constant outside integral sign, integral of exponential 4t. So you have q dot exponential 4t, it's equal to, how do you solve this? This becomes 12. In integrating exponential term, what's the concept? Take this one here, exponential 4t. From your part there, differentiate 4t with respect to t. What do you get there? 4. That 4 becomes denominator. Basically, this is how you integrate this. Then plus c, your constant of integration. Likely, so anybody here? Okay, this gives you q exponential 4t is equal to 4 here 1, 4 here 3. That gives you 3 exponential 4t plus c. You have this. To get q, I'll divide here by exponential. divide by exponential 4t, q exponential 4t all over exponential 4t is equal to 3 exponential 4t all over exponential 4t plus c all over exponential 4t. From here, this cancels this. You have that q is equal to, this cancels this, 3 plus c all over exponential 4t. You have this. All right, so what do you have here? Let's express this one here in index form. Have that q is equal to 3 plus c. This in index form becomes what there? Exponential minus 4. So the concept is simply put minus to this. That's all. Becomes minus. So we have this as my answer. They give you a condition there that at q of 0 is equal to 0. What does this mean? This means that at q equal to 0, t equal to 0, initial stage. That means this one here, let's impute that value here. At q equal to 0, 0 is equal to 3 plus c exponential minus 4t is what there? 0. So I have 0 is equal to 3 plus c. This becomes minus 4 times 0 is 0. Exponential 0 is 1. 1 times c is c. Move this man over here, becomes minus 3 equals c. Let's substitute into, let's sub this into this one here. Let's call this asterisk into asterisk. So substitute into asterisk. I have q is equal to 3. What's plus c? What's plus c? What's the value? So minus 3. In place of plus c, I'm putting minus 3. Then this exponential minus 4t. If I factorize this, you have that q is equal to 3. Of course, 3 divided by 3 gives you what there? 1 minus, take off 3 here, you have this exponential minus 4t. This becomes the answer to this. So you should find q. And also what there? I. So we've gotten the equation for q, which is this. One last thing, let's get I. Also find the charge and what there? The current. For I, what do we know? We know that I is equal to what there? The q all over what there? The t. To get the value of I, simply differentiate q with respect to what there? T. To make this differentiation easy for ourselves, what we'll have to do is I will take this one instead. This one is the same thing, but this one is easier. So we now have that I is equal to d over the t of q. Because we said d over the t of q. What's the value of q? Let's use this one here. 3 minus 3 exponential what there? Minus 4t. So we have this. So how do you differentiate this? I is equal to, if I differentiate constant, then what do I get there? 0. It's off. So it becomes this one here, minus 3. Differentiate exponential minus 4. What do you get there? Times. To differentiate an exponential function, what do you do? Differentiate the power. If I differentiate minus 4t, what do I get there? Minus 4. Use it to do what there? Multiply what you have there. Please, that's how you differentiate. If I'm integrating, where's that stuff there? If I'm integrating, see here? Now clean it. If you want to integrate this, differentiate the power and divide. That's how you integrate. If I want to differentiate the power and add it to this. So it becomes differentiate minus 4t, you have minus 4. Use minus 4 to multiply this. And of course, your minus 3 here. So I is equal to minus times minus plus 3 times 4, 12 exponential minus 4t. So basically, this is the charge you ask to find, and this is the current you ask to find. So that's how you solve this. So they say find the current at t equal to, put the value, you have an answer. Find the charge, of course, current in amperes. Find the charge at t equal to, put the value there. For charge, what will be your unit? Coulomb, that's C. So basically, this is how you solve this question. So this is how the RC series circuit works, right?
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description. Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.